to all presenters and participants of session B1. This is session B1, day 1 of BIPAMA conference 2021. Okay, at first, on behalf of the organizing committee, I would like to thank all presenters, all contributors to this conference. Okay, I will chair this session with Dr. Midani, and also will be helped by Miss Lopna, yeah? Miss or Mr. I think Miss, yeah, Dr. Midani.
Yes, Miss Lobna.
Miss Lopna. Okay, so today we'll have five papers to be presented in this session B1. So hopefully everybody's are here, the presenter. Okay, so I would like to remind once again, yeah, to all presenters that you have about 10 to 15 minutes for presentation, and then it will be continued with like 5 minutes, yeah, about 5-minute question and answer. Okay, so so hopefully all presenters are ready. We will start with, inshallah, the first one is Dr. Midani, yeah. Dr. Midani, yes, okay, it is on the screen. The title is Date Palm Fiber Composite, Processing, Properties, and also Application. Very interesting topic, yeah, by Dr. Midani. Okay, welcome, Dr. Midani. Okay, start with your presentation. Unmute, Dr. Midani. Dr. Midani, you have to unmute at first.
So
okay.
So now can you see my screen?
Yes.
Okay, thank you so much. Okay, so good morning and good afternoon, everyone. It's such a pleasure to be here with you today. My name is Muhammad Midani. I'm an assistant professor of materials engineering at the German University in Cairo. And I'm also an adjunct assistant professor at the Wilson College of Textiles, North Carolina State University. And this is actually where I earned my master's degree in textile technology and management, as well as my PhD in fiber and polymer science. And I'm also the managing partner of a technical consulting company called Intexive, which is specialized in textiles and composites. Okay, so date palm fiber. What actually is date palm fiber? I mean, is this like the fibrous mesh that surrounds the date palm trunk? Or maybe it's some sort of dietary fiber that is present in the palm fruit itself, or perhaps it's some sort of like wooden fibers obtained from grinding the byproducts of the date palm. Well, I mean, it took me some time to figure out actually what is date palm fiber. And coming from a textile background, actually none of the available definitions satisfied my personal understanding of a textile fiber. As most of you know, that the basic definition of a fiber is the aspect ratio, which is the ratio between the fiber length and the fiber diameter. And as this ratio increases, the fiber becomes longer and thinner. And this is actually how people define a fiber. And this wasn't actually the case for what is available as date palm fiber. But I was still, one thing that I was sure about is that it's some sort of sustainable, natural fiber. And this for me was exciting enough to start exploring and learning about this amazing material. And as most of you know, that natural fibers can be classified into like vegetable and animal fibers, and they can be further classified depending on the source from which they are obtained. So for instance, vegetable fibers can be classified into bast fibers, and these are the fibers extracted from the stem of the plants, as well as leaf fibers, and these are the fibers extracted from the leaves. And then like the seed, these are the extracted from seeds like cotton, and the fruit fibers. Likewise, we will find the animal fibers, including the wool, silk, and feathers. Okay, and actually by looking at the different byproducts of pruning of date palm I found them very diverse, including like this beautiful fibrous sheath that surrounds the trunk, in addition to the front stalk, the fruit stalk, and the leaflets. And I thought, okay, I was able to relate with what I understand about leaf fibers. And I thought, I think we can extract textile fibers from these byproducts, okay? And I found out that every part of the date palm fiber contains, date palm contains fibers. Every type of byproducts can be extracted into fibers, like the front stalk, the leaflets, the fruit stalk, the sheath, and even the trunk at the end of the fiber, at the end of the palm life. But the biggest challenge here is that every type of these byproducts have a different type of fiber. So in order to be able to extract those fibers, we need to have a very good understanding of the microstructure of those fibers. So for instance, we will find that the front stalks are composed of like fiber vascular bundles, which are characterized by the large voids or lumens, whereas the leaflets and the fruit stalks are characterized by, or they are composed of pure fiber bundles, whereas the sheath or the fibrous mesh, it's a bit different. It has this unique cellular structure. So we need to clearly understand like the differences between those microstructure in order to be able to extract textile fibers. And it actually, I started like reviewing every published research on date palm fibers that in the literature. And I found, I mean, it was a very tedious job and it took some time. And I found that like, you know, that like all the information are scattered and full of ambiguities. You know, even like in simple matters, you will not like terminologies, for instance, we will not find any like consensus or agreement on a set of terminologies. So one thing that we personally call front stalk, others might call it midribs, or might call it like rachis or petioles. So it was actually confusing. So we started thinking, okay, and we found out that, you know, there wasn't any review articles or even published book on this topic, date palm fibers. So we thought, okay, so let's fill the gap in the literature and prepare a review article. And it was the first review article. I mean, it's a nice article that was published in Springer Cellulose, and it was authored by Lobna. And then we thought, okay, so let's extend this work and expand it and prepare a book that might act as a body of knowledge or a handbook for researchers who are and practitioners who are working in this area, that would include up-to-date information on date palm fibers and their composites, including processing properties and applications. And we started working on this book project with the support of my co-editors, Professor Nahid Saba from University Putra. Yes, University Putra, Malaysia, as well as Professor Othman Al-Othman from King Saud University in Saudi Arabia. Okay, and the book is actually divided into 4 sections. So the first section, it provides this historical context and time horizon of utilizing the different types of date palm byproducts over the years. And it includes like up-to-date information on date palm statistics and distribution, as well as a very defined description of every byproducts and their annual quantities, in addition to the traditional applications and the technological heritage that is available in different regions around the world. And this section also was prepared by the legendary Professor Hamid al-Mosli, and it includes more than 100 original photos that is from his personal photo library. Okay, the second part, or the second section, it's on composite processing, the date palm fiber composite processing, including chapters on like date palm fibers extraction and treatment techniques, preform formation methods for composites, different types of polymer matrix systems that are suitable for date palm fibers, as well as the up-to-date composite fabrication methods that is compatible with the date palm fibers, in addition to other topics like nanofibers and design and modeling. The third section is actually on the date palm fiber composites and their properties. It includes chapters on like fiber characterization and date palm fiber composite testing and properties, as well as a specific chapter that compares the date palm fibers with other commonly known fibers, and a chapter on the effect of environmental conditions and how the date palm fibers is capable of resisting the harsh environmental conditions. And the last section is on the applications, with 4 dedicated chapters for each application. The first one is on construction and building. The second one is on wood substitutes. The third one is on the automotive applications, and the fourth one is future applications, including nanocomposites and nanofibers. So this book was actually one step towards our work that helped us in developing the first textile fibers and reinforcements that are extracted from date palm byproducts, including the front stalk and the fruit stalk, and we call it palm fill. And it's a very versatile fiber that can be processed into different textile forms, including hackled tows and spun yarn, and it could be chopped and cut into chopped fibers, and could be converted into non-woven mats or woven fabrics, or blended with like a polymer matrix and pressed into a high strength, low weight composite materials. And actually, palm fill fiber has a unique set of features and benefits. I mean, it's very sustainable, and it's 100% biodegradable and carbon dioxide neutral. It's abundant, and I mean, the estimated annual availability of such fiber is almost 1 million tons per year. And it's economical in manufacturing, doesn't require any extra investment in water, fertilizers, or land. After all, it's a byproduct, and it's considered an agriculture waste. Also, it's a high performance fiber. Its specific tensile strength is 5 times higher than structural steel. And when it comes to weight, it's 50% lighter than glass fiber, and it's safe for the working environment and doesn't require any special like personal protective equipment. And most of all, most importantly, it's compatible with the existing textile processing systems, like for spinning and weaving, and it can be blended with other natural fiber. And we did actually an extensive research and development to optimize the extraction process and characterize this new extracted fiber. And the results were published in some of the like known prestigious scientific journals like Industrial Crops and Products, as well as Springer Cellulose. And we had this passion for commercializing this new technology, driven by a strong belief on the impact of such innovation on the sustainable development of rural communities. And we've gone through like the proof of concept to the prototype development, and we're currently in the pilot stage, and we're seeking partners to support in building a pilot plant and further scale up and commercialize this technology. And as soon as we've announced we did the commercial announcement of palm fill last summer. It received a great deal of media coverage. It was featured in more than 30 specialized press articles in almost 14 different languages and different countries. And it was featured in the technology spotlight of the International Fiber Journal, as well as the International Directory for Biobased Businesses by Nova Institute. And recently it has been added to some of the international materials library, including like Brain of Materials in Germany, as well as Material Connection in the United States, with the Material Connection Seal of Material Excellence. And we've been actively communicating this new innovation to all stakeholders. We have prepared a website for this new fiber and a brochure. And before I would like to conclude about like the impact of such project, we strongly believe that of the impact of such project, and that this is a very promising new natural fiber. Think of the potential of converting or creating value out of the agricultural residues of the 140 million date palms around the world, or even like with the potential of extending this innovation or technology to apply for other palm species such as oil palm and coconut palm, which have even greater population than date palm. And finally, our major goals for this project, Palm Fill project, is to scale up and commercialize an innovation that benefits the economy, the society, as well as the environment, and to create value from the agricultural waste from date palm byproducts, and also to add a new natural fiber to the natural fiber library and increase the biodiversity of fiber crops, and also to provide the industry with a sustainable raw material that can help them become greener, and also to build and support the sustainable development of rural communities and build circular bioeconomies based on this new innovation. And finally, to preserve the cultures and the technical heritage of the local communities. I think I have 2 more minutes. I will quickly finish. The development team of Palm Fill project is actually have they have more than 50 years of combined experience in fiber science, textile technology, as well as like composite engineering. In partnership with our partner, Dr. Tamer Hamouda, our technology management expert, and Dr. Ahmed Hassanin, our industry expert, as well as our young scholar, Lubna El-Saifi. And before I conclude, I would like to dedicate this book, and as well as our work, to my mentor, the legendary Professor Dr. Hamid Al-Musli, the founding father of palm byproducts research and development, who has laid the ground and inspired generations of researchers and practitioners who are working in this area. With that, I conclude, and I would like to thank you so much for your attention, and I would be happy to answer any of your questions. This is the link for the book, and this is the link for Palm Fill website. And if you have any question, please feel free to email me. Thank you so much.
Thank you very much, Dr. Midani. What a very interesting presentation. I would like to open for question, like 2 minutes, 1 to 2 minutes. Is there any question from our participant?
Yes, sure.
Hamid is here.
Yes.
Yeah, the founder.
Yes.
The founder of the date palm, yeah, byproducts. Okay. Is there any question from the participant?
Yes. If you have a question, I think Dr. Kais has his hands up. We can ask to unmute.
Okay.
Yes, please.
Yes, please.
Thank you very much, Professor. Thank you very much, Professor Midani. I will congratulate you for the editing the book. I had the opportunity to participate in this book. My question, the quality of your work, I think that's it's not a question, it's the recommendation. To enlarge this experience in in other kind of fiber. I don't know if you are thinking about the use of comparison between the palm fiber and other fibers.
Yes. So in the next presentation, which will be presented by Lobna El-Saifi, so she's doing a comparative study between these type of fibers compared to other leaf fibers, including the sisal, the manila, and the banana fibers. It's very important to have this benchmarking. So it will be presented in the next presentation.
Thank you, Dr. Midani. Prof. Basim, do you have any question? Unmute, Prof. Basim.
Okay, so Prof. Basim, can you?
Okay, yeah. Thank you, Dr. Muhammad, for this nice introduction. It seems it is an interesting book, actually. Now, in general, based on your experience, what is the main advantage, actually, here of maybe my question is in the same context, actually, here of the previous question, but what is the main advantage of the date palm, actually, here fibers over the other, actually, here existing fibers now?
Okay, yes, so this is a very important question. So let me tell you one thing. If we look at the library of the natural fibers, let's first agree that there's a very strong movement towards the sustainable raw materials and the bio-based material. I mean, the industry is now very hungry and thirsty for having like a sustainable alternative to the existing synthetic materials that they are using. If we look at natural fibers, unfortunately, we will find that the library of natural fibers has not changed for thousands of years, okay? And if we further look at this, we will find that almost natural fibers are dominated by cotton fibers. Like cotton represent almost more than 85% of the world production of natural fibers. Like the other remaining quantity is like 5% of jute, 5% of wool, and that's it. And the other like natural fibers like sisal, manila, banana, pineapple, kinaf, hemp, they only represent a very small fraction, and they are not available in large quantities. So this lack in biodiversity is a problem, and we think that date palm fiber can represent a solution to this lack in biodiversity. We think that we have the ability to introduce a new fiber with the possible annual fiber availability of almost 1 million tons that can rank third after coconut, after cotton, jute, and coconut. So this is one of the greatest advantage. I don't want to take too much time to allow for subsequent like presentations, but we can continue our discussion in the chat or in the WhatsApp room. Thank you so much.
Question.
Thank you.
Also, there is one question from Lasari. Dr. Midani will answer in the chat box, yeah?
Yes.
Okay, thank you very much, Dr. Midani, for the presentation.